that with someone easily. And we believe that there can be a method that is fast, efficient, effective, and non-invasive. And computer vision has been used in object tracking, object detection, and semantic segmentation in the past with good success rates. And we believe that we can implement that in this situation as well. For our project, we implemented YOLO version 3 and faster RCNN. And we had 5,800 images for training, and 600 images for testing. And our faster RCNN had a 93% accuracy rate, and our YOLO version 3 had a 99% accuracy rate. And we believe this is a state-of-the-art performance from our projects. And we also compared the performance against the ones in literature. And as you can see you can't see properly, but our project outperformed all the others that we found in literature. And we believe for future work that curating a data set that is made up of inebriated people and non-inebriated people will create interest in this research and push this research forward. Thank you.
You're welcome. Okay. Ooh. The Aries CH project, Artificial Intelligence for Digital Restoration of Cultural Heritage using Nuclear Imaging and Multidimensional Neural Network. 2 minutes.
Hi, everyone. I am Alessandro Bombini of the National Institute of Nuclear Physics, and maybe you may wonder why I'm here. The fact is that we have a group devoted to the application of nuclear techniques like nuclear imaging to the fields of cultural heritage, and another group to develop software for physics and applied research. So we join forces and we start analyzing our data about nuclear imaging on cultural heritage, in particular on pictorial artworks. And that's nice because nuclear imaging gives a new perspective on how to look at especially damaged paintings. So the idea is to use multidimensional neural networks, so like 1D and 2D together somehow, in order to have a fast digital reconstruction of damaged paintings and to offer them in cloud services on our service. If you are interested, please search me. Bye.
Thank you. Don't wait until accident happens. For short classification framework for car accident inspection in a real world. No one? Okay. Efficient transfer learning or visual task in continuous optimization of prompts. No one. A two-step radiologist-like approach for COVID-19 computer-aided diagnosis from chest X-ray images. 2 minutes.
Hello, I am Enzo Tartaglione and he is Carlo Alberto Barbano. Yeah, it's 2020, there is the COVID pandemic, and there is lackness of swabs, and it is very difficult to perform tests for COVID. One possibility was explored, which was try to diagnose COVID from chest X-rays. How do you do that? Well, you can train, for instance, end-to-end a deep learning-based model. But that's not very explainable, because, of course, you need to guide the radiologist to perform some diagnosis. So, what's the approach they typically do? They find what they call the radiological objectives. So they are lesions, which are very well known from the literature. And then, depending on how they show off, a diagnosis is elaborated. And of course, if you try to train deep learning models on this, you need to make all the decision process as clear as possible. And this is why we propose a two-steps learning approach.
Yes, and that's not only helping with explainability, because if you remember in the start of the pandemics, datasets were very small, so what we had to do was to use external datasets, publicly available, usually to get more negative samples, because at the time every patient was positive, of course. And what could happen is that models ended up actually classifying datasets and data sources rather than the actual disease, COVID. And so this kind of approach is not only helping in explainability points of view, but also gives a very good pre-training task in order to get a much more robust model when doing classification of small data. So if you're interested, come talk to us. Thanks.
Thank you.
Thank you. Robust object detection with multi-input, multi-output, faster RCNN. No one. In our extensive experiment, we found the CNN perform better on EEG data. EEG data, sorry. A two-stage U-net to estimate the cultivated area of plantations. Super resolution of solar active region patches using generative adversarial network. Unsupervised detection of dynamic hand gesture from lap motion data, deep motion data. 2 minutes.
So, hi everyone, I'm Alessandro Simoni from the University of Modena and Reggio Emilia. And I would like first to mention the main contributor of this work that could not be here in person, that is Andrea Desanio. So basically in our work, unsupervised detection of dynamic and gesture from lip motion data, we propose an unsupervised method to jointly detect and classify the hand gestures in dynamic sequences. So basically, the main contribution of this work is that in comparison to traditional methods that requires a lot of label data containing the detection of each gesture in the sequence and also the class of each gesture, we propose a transformer-based architecture, which is trained in a specific way using a CTC loss that basically jointly detect and classify the gesture in the sequence. The importance of classifying and detecting hand gestures in sequences is especially it enables the applications in natural user interfaces, which allows to interact with systems with free movements of your body without using mechanical tools. So if you're interested in our work, you can reach me out in person or join me in the virtual session. So thank you.
Thank you. Improving colon carcinoma grading by advanced CNN models.
Okay, thank you. My name is Marco Leo, and I'm going to present you our work about colon carcinoma grading. In particular, in this work, we address the problem of detect the carcinoma in histopathological images and also to grade the carcinoma regions. Where grading meaning that we want to predict the life expectation of the patients. So what we did is just to see that most of the network that have been already used in literature are not up to date. So we consider the CRC extended dataset and we test on that dataset the most up-to-date architecture. In particular, we also tested the model design system that is able to tune hyperparameters of the architecture, and then to optimize the architecture for, in general, object detection and recognition, but also in this case for carcinoma region detection and grading. So what we obtained is not possible to see here, but is that most of the network we used improved the state-of-the-art in detection and grading of the carcinoma with respect to the methods already in the literature. So if you are interested in to see which network we used and how we exploited them in our work, feel free to reach me out here in person or by mail or wherever you want. Thank you very much.
Thank you. Comparison of different supervised and self-supervised learning techniques for skin disease classification.
Hi everyone, I'm Loricino. I was a student at University of Salento, and during my thesis, I with Professor Costantante and Prof. Mazzeo, I studied several techniques, I applied several techniques of machine learning, supervised and self-supervised learning on skin issue classification. I used the ESIG dataset, especially the 2019 version of this dataset, and reach the state of art in this task. The previous state of the art was around 80% of balanced multi-class accuracy. We use balanced multi-class accuracy because these kinds of datasets are high unbalanced, and we reach 87 of balanced multi-class accuracy, which is pretty much improvement on the previous step of state of the art. But a part of our work focused on self-supervised learning, which this self-supervised learning in image computation is we use it is on well-known datasets like ImageNet or CIFAR, and we apply this technique on challenging datasets like ESIG, and we proved that this improved the performance, but also we proposed a new self-supervised pipeline, which is start from fine-tuning from ImageNet weights, and then applied full self-supervised pipeline. If you're interested, you can contact me or Prof. Distante or Prof. Mazzeo in person or by email. Thank you.
Thank you. Improving autoencoder training performance for hyperspectral and mixing with network reinitialization. Now one. ADC's classification using deep learning.
Hi, my name is Patrycja Haraburda, and I am from Warsaw University of Technology. I want to present to you my work that was done as a part of my master thesis. And in this work, I focus on fundus photography for classification of eye diseases. From the diseases, I classified such ones as diabetic retinopathy, glaucoma, cataract, and of course, normal ones. What is important to remark is the fact that in the literature, there are many works that present individual eye disease classification. However, there are none that focus on the multi-class solution. And it was done in my work. And as a first part, I managed to collect a 30,000 images data set composed of individual open access datasets. And in order to classify the images, I use a synergic deep learning model that was previously proposed in the literature. And it was particularly designed for medical imaging problems. And it also proved good results for my case. And so overall, I managed to achieve a 70% accuracy for 4 classes, 3 diseases and normal. But I believe that this outcome can still be improved. So for the details, I encourage you to read the paper and see the poster. And of course, you can ask me in person. Thank you.
Thank you. Oh. CVGAN image generator. Oh. Optimized fusion of CNN to diagnosis pulmonary disease on chest X-rays. A lightweight model for satellite pose estimation.
Good afternoon, everyone. I'm Pierluigi Carcagni, and the topic of my work is related to the main non-3D pose estimation in space in non-cooperative context, and by means only using one monocular Greek camera. Typical configuration in this context consists of one target object space, one chaser object that need to know the 3D pose relative in order to accomplish these rendezvous operations. In this work, we have investigated a two-step processing pipeline, starting from the input visual page that contains the target vehicle. We, in the first step, estimate a prefixed set of landmarks by means a lightweight CNN. In the second step, after 3D correspondences, we estimate the final 3D pose by means of PNP algorithm. Obviously, we need to know 3D model of the target in order to perform the correspondences between the estimated landmarks and the corresponding 3D. The methodology showed good results both in terms of accuracies in pose estimation, in particular for close range distances, and showed good results in terms of footprint of the obtained model, making the model deployable on real hardware typically used in little satellite platforms. If you need any questions, please send me a mail, or you can find me at the registration desk here in the hall. Thank you.
Thank you. Forecasting future instance segmentation with learned optical flow and enveloping.
Hello everyone, my name is Andrea Ciamarra, a PhD student at the University of Florence, Italy. And in this paper we are introducing and dealing with understanding urban environments from an ego-vehicle perspective. This can be very important for safe navigation. And this problem can be seen under different points of view, such as detective entities, understanding road layout, and predicting the future. Moreover, different modalities can be exploited to understand the environment, like RGBs, depth maps, or data coming from more complex sensors, like LIDARs, event camera, or thermal camera. We focus on predicting future instance segmentation of moving objects, since we believe it is the most informative representation for driving branding motion. Existing state-of-the-art using different modalities with several optimization stages. Instead, we study how we can rely on optical flow as a unique source of information. To do that, we break down the problem in 2 steps. We first design an optical flow predictive model, which generates future flows given the past ones. Then we design a novel mask prediction model, which warps binary mask onto future frames by given the estimated optical flow, which is the predicted optical flow, and the current semantic segmentation, which is the present. We can discuss in my poster. Thank you for the attention.
Thank you. Learning and Rayleigh-based neural network for magnetic resonance imaging reconstruction. Now one. Investigating one-class classifiers to diagnose Alzheimer disease from handwriting.
Good afternoon. I'm Antonio Parziale. I'm postdoc at the University of Salerno, and I am a member of the National Computational Laboratory directed by Professor Angelo Marcelli. Since 2015, we are working on handwriting analysis as a digital biomarker to diagnose neurodegenerative disorder like Parkinson and Alzheimer. Studies on neuroscience and motor control have shown that the analysis of the kinematics and dynamics of handwriting is a viable tool to detect the early symptoms of these disorders. Moreover, the administration of a diagnostic tool, a diagnostic test based on handwriting is cheap and non-invasive. Because you need only a scanner, a phone, or a tablet. Nevertheless, up to now, there are few public datasets, and those datasets are made up of a few samples drawn by few dozen of subjects, because it's really complex to collect data from patients. In fact, patients need to be reached at their living place, and in some cases, it is required the presence of the medical personnel. In order to overcome this problem, we propose to use one class classifier trained only on a sample collected by healthy subject. And therefore, we diagnose the disorder as a deviation respect to this model. We have compared different one-class classifier, and the top performing one is the negative selection algorithm, which mimic how our immune system works. I don't want to spoil more about the paper. If you are interested, please join the poster session. Thank you.
Thank you. Spatial temporal autoencoder with attention network or video compressions. Now one. Test time adaptation for egocentric action recognition. Now once again. Foreground detection using an attention module and a video encoding. Depth-aware multi-object tracking in spherical videos.
Hi, I'm Liliana from the University of Palermo. So in this paper, we are going to present a work about multi-object tracking in spherical videos. So which basically means that we propose a tracker is implemented by following a standard pipeline, in the sense that we are considering a tracking by detection approach. So we are also using a pre-trained detector to detect a person in the image. Then what we are doing is just solving a data association problem to associate identities to the pedestrian we detect in each image. So what's really novel and interesting in this paper is the kind of images we are processing, because we are considering rectangular images which are collected by means of 360-degree cameras. And this kind of camera are composed by two sensors, each one acquiring a part of the scene, and then the images are stitched to create a panoramic image. So basically, with just one image collected at each timestamp, we can basically monitor the whole scene. What then we do is basically detecting pedestrian, and the other novel part is that we are able to do tracking on the ground plane without using any calibration procedure, because due to the geometry underlying this kind of a projection, we are able to find the 3D position of the person in a reference system centered on the camera location. And thanks to this 3D location, we can do basically 3D tracking. And if you are interested, please come to visit us. I will be online. Thanks.
Thank you. Machine learning to predict cognitive decline of patients with Alzheimer's disease using EEG marker, a preliminary study. It seems no one is here. CFAR, vehicle speed estimation and flow analysis from a moving UAV. The automated temporal analysis of gates following a visual tracking task. No one. On the evaluation of video-based crowd counting models.
Hello to everyone. My name is Emanuele Ledda from the University of Genova in collaboration with the University of Cagliari. And our work is about evaluating the video-based crowd counting models. In general, the problem is about counting the number of people on images. So traditionally, the problem is addressed by using a crowd counter that works on single images. So if we want to use it on videos, we simply use it for each frame of the video. But more recently, someone is trying to use also the temporal information given by the sequence of frames. So in this problem, we have to know how to evaluate the temporal contribution given by adding the temporal information. So we address the problem for a particular category of video-based crowd counting models that are the type of models that use crowd counter that works on images as a backbone for extracting features from each image and then concatenating those features and using a video module for refining the prediction. And in this work, the evaluation method consists on using the video-based architecture and comparing the result with the backbone. And they measure this gap that is considered the temporal contribution. But we hypothesized that this can be misleading because adding a new module can also give a spatial contribution. So we try to use the video-based architecture with n frames in a video-based setup, and then the same network with one single frame, and then comparing this gap. If this gap is smaller than the previous one, then that means that maybe the addition of the new module can give also spatial contribution. And we validated this approach using two state-of-the-art models and 5 benchmark datasets. And the results just confirm our hypothesis. If you want more details, you can join our virtual poster session. Thank you for the attention.
Thank you. Leveraging cycle GAN in lung CT cyanogram-free kernel conversion. It seems no one. And it also seems that this is the last poster. So thanks for joining this poster session, and enjoy the coffee break if something is still there. And so that's it. Thank you.